Welcome to the project demonstration of comparative performance analysis of fuzzy logic and PI controller for MPPT in PV systems. So in photovoltaic systems, in order to achieve the maximum power point tracking system along with boost converter in order to drive the load and also charging of this battery pack. So we are making use of this system, so which is easy to control the two ways. One is MPPT with the help of this MOSFET, and next buck boost converter, the DC to DC boost converter with the help of this boost converter circuits, and these two are the plays major role in order to control this maximum power point tracking. So in MPPT we need to control the voltage. So though we are using the solar panel of 12 volt, so here the rated voltage from the solar panel is, when we are placing this under the full sunlight, the output voltage as we mentioned over here. So this voltage maximum power is 17.5 volts, 7.4 volts, and maximum power is 5 watts, and current 0.29, as well as open circuit voltage is 21 volts. So here the main point is we need to note it 21 volts means when we place this kit under the sunlight, the solar panel will provide us, it was designed for 12 volts DC. Generally the charging voltage for our load, which is battery pack we are using, is 14.5 volts maximum voltage is sufficient to charging of battery pack and to run this load. So the remaining voltage, what is excess voltage is there, so that is a wasted, nothing but in order to compensate the power. So as we know that power equal to voltage into current. So whenever we increasing the voltage after the required voltage crosses, then the current will be decreases in order to maintain the 5 watts of power. So if you get the 14.5 volts, then there will be I value will be there. So if the voltage is increasing from 14.5 to 16, 17 like that, parallelly, proportionally the current value will be decreases. So then we can't get the maximum power over there. So the voltage will be wasted. In order to compensate that current to get the maximum power, we need to do this MPPT with the help of this MOSFET. We are going to regulate the voltage, that is the buck the voltage. So after the bucking the voltage, whenever the voltage is above 14.5, so our Arduino Uno, which is a main controller, which is a fuzzy logic controller, we are using this to measure the voltage continuously from the solar panel with the help of this. So the solar panel input to this, parallelly that was input to this our charging circuits to this voltage sensor, and here also we are using the current sensor. So the voltage and current continuously measured by this Uno board, and that will be displayed on this LCD screen. Whenever the input voltage crosses 14.5, then we can see the PWM signal on the LCD also. Will show you the demonstration stages. So that PWM will be decreases in order to buck the voltage with the help of this so-called MOSFET. And whenever the voltage is above 8 volts below 12.5, and that will be boost up to the charging of this battery pack with the help of this boost converter. So these two are the main outputs, and voltage sensor, current sensor as the input to the Arduino Uno board. So here the major these features of the project to be executed based on this two sensors inputs and controlling the two outputs. And remaining components is, so we are using here LM2596 voltage regulator, which will take 12 volts DC inputs and provide us a 5 volts DC output, as the operating voltage of our system is a 5 volt. And this one is the inductor. So these are the star transformer. We are using the primary coils, the primary turns, we are using them as a inductor in our boost converter. And this one is a breadboard, just to distribute the 5 volts power supply to the input output modules. And this is extra charging circuit, which is not the part of the project. So while we demonstrating the project, if sunlight is not available, just with the help of this grid power supply, with the help of the transformer, we can charge a battery pack. So just connect this 2 pin at this slots as we shown here. Okay, so in this manner connect the battery over here, and now on the power supply to the transformer. So before demonstration, keep the battery under charging at least of 4 to 5 hours. Till the duration, keep the charger on only. So once the charging completion of this time duration, then you can remove this. So as we discussed initially, this is not the part of the project, it's the grid station to only charging of this battery pack. Okay, and the next, coming to the ratings, we are, as we discussed, we are using the 12 volt 5 watt solar panel, 12 volt 2 amps battery pack. This battery pack consists of 6 4 volt 1 amp batteries. In the 3 are in series, so we'll get 12 volt 1 amp, and these 3 are in series, so we'll get 12 volt 1 amp. These 2 are in parallel, so we'll get 12 volt 2 amp DC output. That is a main load to the solar panel for charging purpose. And we are using the 3 watt 12 volt LEDs just for showing the visual load here. And as we discussed, the components are voltage sensor, current sensor, charging circuit from the solar panel, and the boost converter and MPPT circuits, and this one is a regulator for power supplying the system, Arduino Uno board which is acting as a controller here, and breadboard, LCD display to show the status, and this is the inductor and the load here. Okay, coming to this charging circuit, as you can see there are the 4 diodes are placed. So you can see that both charging circuits are same. So here these 4 diodes will acting as a rectifier when we getting the input from the transformer, that is AC will be rectified to pulsating DC. Remove the ripples will be done by this capacitor, and 2 diodes will acting as a unidirectional current flow purpose, means it will allow the current from transformer to the battery, it will block the current from battery to the transformer in order to protect the reverse current protection. Same components are present on this charging circuit which is of the solar panel, but on these 4 diodes will acting as a polarity corrector. As we know that we are getting a DC power supply from this solar panel, so which has a polarity based power supply, and when we connecting that to the battery we should always check about the polarities. So if we place in mispolarities, is wrong polarities, so then the reverse polarity may damage the solar panel or battery. So in order to protect that reverse current protection, so we are using this polarity correction purpose, we are making use of this 4 diodes. So in this one, these 4 diodes will acting as a polarity corrector, and remain two diodes same as unidirectional current flow capacitor, just to minimize the ripples while we are executing the project. Let us see the demonstration. So once we on the power supply, so this is a load on off switch. So on LCD we can see the voltage, solar panel voltage is around 1.9. just load over here, we can see the when we cover the solar panel the voltage will be decreases, and just we on the power supply and on more lighting on the solar panel, so we can see the voltage is increasing on the LCD as well as PWM slowly decreasing. Whenever the voltage is above 5 to 6 volts, then we get the proper current value of the solar panel on this LCD screen. Right. So based on the solar panel voltage, the PWM will be controlled, and this is directly to the load connection. Thank you.